Okay, I will start my presentation. The title of my talk is How Weak Reference is Used in Java Project. My name is Yoshihiro from Osaka University in Japan. Okay, let me start with the explanation of garbage collection. Garbage collection is an automated memory management system. It's collect unreferenced object, and then it's free memory occupied by such object. But garbage collection has a weak memory leak problem, which means referenced objects are not collected. So unnecessary referenced object causes memory leak. To avoid this problem, Java introduced weak reference. Weak reference, in short, WR, weak reference can instruct Java VM to collect object. This means object referenced only by weak reference are collectable by garbage collection. So in this presentation, usual reference is called strong reference. And in Java library, there are two classes for weak reference. The one of weak reference and the other is weak hash map. And here is an example code of weak reference. At the top of code, a weak reference is created for a given new object here. And then there are some processing here. And in the line 90 here, null is returned if the object has been collected. So at the next line, there is a null checking. This is a typical code of weak reference. But it is difficult to use weak reference because it requires deep knowledge. So developers need to know when object will be collected by garbage collection. If an object is collected in improper way, improper timing, null pointer exception will happen. But at this moment, we cannot find any research that investigate how weak reference is used in the wild. So in this research, we investigate how weak reference is used to understand weak reference usage situation in real software systems. In this research, our target is Java project in GitHub. We conducted 6 research questions in this research, but due to time limitation, I talk about only 3 of them. In which domain weak reference used, and how weak reference is used, and is using weak reference effective for performance. Okay, let's go to the first topic, domain. In this investigation, we used Borges dataset, which includes about 200 Java projects in GitHub. In this investigation, we used GitHub's API to search code that include weak reference. Here is the result. The x-axis means list of domains: application, system, web, non-web, tools, and doc. These categories are created by the dataset authors. And yellow bar means the number of applications, number of systems included in the domain. And blue bar means the number of systems including weak references. By using this graph, we can see that weak reference is often used in system domain and the tools domain. Okay, next I talk about the usage. In this investigation, we used the top 10 starred project in the dataset. More concretely, we investigated 95 files including weak reference. And we conducted manual investigation to reveal how weak reference used. And as a result, we found 6 patterns that are testing, memory leak prevention, caching, API implementation, comments, and unnecessary processing avoidance. And this graph shows the result. X-axis list the 6 patterns, and y-axis means the number of files. By using this graph, we can see that weak reference is often used in testing and memory leak prevention. And here is an actual code of for testing. At the top of code, here a weak reference is created for the input. Here, input is D, and then do something for the input D. And at the bottom of the code, garbage collection is forcibly triggered by using this instruction. By using this code, the developer verifies that the input does not cause memory leak. I show another example. This example code is for memory leak prevention. In the line 4 and 5, this code checks if the object has been corrected or not. And if the object has been corrected, makes it again in this code fragment. And then in the line 9, there is a main processing. By using this code, developers can avoid memory leak by using weak reference. Next, I talks about the performance. In this investigation, we used a software Grade. This is an image loading library for Android. And we used original Grade with weak reference, and we also modified Grade not to use weak reference and compare the performance of them. In this investigation, we made Grade load 1.6 gigabyte image data. More concretely, we prepared 400 of 4 megabytes JPEG images. And we prepared emulators, which includes 1.5 gigabytes memory. So in this situation, it is impossible to store all the data in the memory because the memory size is 1.5 gigabyte and all the data size is 1.6 gigabytes. And here is the result. Original Grade with weak reference ran successfully. But on the other hand, modified Grade without weak reference failed to finish running. This is because there are strong references to the image data. So it is impossible to correct them by the garbage collection, so which triggered out-of-memory exceptions. On the other hand, original Grade ran successfully because there were only weak references to the data, to the image data. And this means the object were corrected properly, and which did not trigger out-of-memory exceptions. This slide summarizes the findings of our research. We found that weak reference is often used in systems and tools domain, and weak reference is often introduced when a new function is added. We also found that weak reference is often used for testing memory leak, and we also find weak reference is often not tested. Only 1/6 is tested. And we also found developers sometimes fail to introduce weak reference, and developers can prevent memory leak with weak reference. And this is an ERA paper, so we have some future works. The first future work is we are going to build code patterns for easy introduction of weak reference, because we found some instances that developer failed to introduce weak reference. And then we also develop a framework that suggests developers to introduce weak reference with such code patterns. Okay, that's all. Thank you very much. Any questions?
Okay, thank you. Thank you for your presentation, Yosuke. Yep. Anyone can unmute yourself to ask question. So any questions? Well. Thank you for your presentation again. Thank you.
Okay.
Okay. So you can receive the host. Sorry.
Receive the host.
Just wait.
Okay. Next speaker.
Yes.
Okay.
You can stop your sharing.
Yes. Okay. I stopped sharing.
So the second presentator's paper's title is automatically identify requirements-oriented reviews using a top-down feature extraction approach. So let's welcome.
Hello.
Yes, I can hear you.
I can't share my window.
You can click the share screen.
You can try now.
Can you see
yeah,
it?
I just make you
Oh,
the host.
yeah. Can you see my screen?
Yeah, I can see it.
My name is Song, and today my topic is automatically identifying requirements-oriented reviews using a top-down feature extraction approach. The whole report consists of 4 parts. The first part will give a brief background and motivation. The second part is our method. The third part is evaluation, and the last part is the conclusion. First, introduce the background. Precisely understanding user requirements are essential for software project success. Nowadays, users can directly provide their feedback via online review, resulting in tons of user reviews that are valuable for eliciting user requirements. So, analyzing users' online reviews can help to man user requirements. And user reviews have a large amount of data with diverse content and unstructured. Existing researchers have studied the automatic classification of reviews. They use review mining to classify categories that contain requirements, and some researchers have studied the text feature extraction. They extract requirements from reviews and apply it to requirements engineering. So we think that they have started to establish connections between review mining and the requirement engineering. But they still studied in their own field, but didn't show the connection. So the motivation of our work is to try to make this connection more concentrated and more specific, so that the result from the reviews can be more useful for requirement engineering. As for our proposal, it consists of 3 parts, but I will focus on the first part. First one is definition, concept model of ROR, what we call the requirement-oriented reviews. I will talk about the definition afterwards. And based on the concept model, we systematically derive a set of linguistic rules and to explore text features of RORs. Finally, we classify reviews with machine learning algorithms to according to the text features. Let's start from the first part. Please look at this legend. The blue boxes represent the concepts of the requirements. Such concepts are from the list research. We try to create associations between these concepts. And the green boxes are the reviews categories, which are from Pagano's work. We extract 4 categories related to ROR. And in this paper, we need to create the connections between concepts and the review categories to find out the requirements in a better way. Through this connection, we can accurately and directly find the reviews related to the requirement. And based on these connections and the concept model, we will try to make sense in the second step. The idea is that we try to extract text features to represent and recognize ROR. So we technically derive text features from the concept model we built. We design linguistic rules to characterize what are the requests and how it's connected to the function. Firstly, we extract the element from the RR concepts from the concept model. And secondly, we group these elements into linguistic rules based on natural language knowledge. In this paper, we design 8 rules for RR. And then the linguistic rules clearly correspond to sentence structure, allowing us to derive text features from user reviews. Based on these linguistic rules, we can use NLP toolkit to design semantic patterns that can be used to identify ROR. Based on the above steps, we designed a total of 56 text features, and then we classify reviews with machine learning. These text features can be accessed from Dropbox. Next is our evaluation. There are 2 research questions. Question 1, can our proposal effectively identify RORs? Question 2, which classifier works best? And the data set we use is from Maalej's work. It contains 4,400 English user reviews, including 4 categories: bug report, feature request, user experience, and the rating. For research question 1, we compare our method with 2 baselines. The result shows that our proposal can effectively identify ROR. For research question 2, we test 6 machine learning algorithms, and the result shows the SMO works best. In the future work, we will choose SMO to classify the user reviews. At last, let me summarize our work. We propose automatically identifying requirements-oriented reviews using a top-down feature extraction approach. Firstly, we design a concept model. Secondly, we define meaningful linguistic rules and text features. Thirdly, we conduct preliminary experiments. And in the future work, we will try to find other data sets to evaluate and use deep learning algorithms to improve our method. That's all. Thank you.
Thank you, Ray, for your presentation. So, any questions? And any questions? Okay, there seems no question. Thank you, Ray. Thank you again for your presentation. Well, let's welcome for the third presenter. His paper's name is CLIONE Modification Support for full request-based development. Let's welcome.
Thank you. I cannot share my desktop. Oh, thank you. I cannot. Just a moment.
Okay, can you try now?
Okay. Thank you. Okay, can you see? Okay.
Can see it.
Hello everyone, I'm Task Nakagawa. The title of my talk is CLIONE Modification Support for pull request-based development. First, I talk about code clone, in short, a clone. Clones are code fragments that are identical or similar to other code fragments in source code. It is said the presence of clones affects the software maintenance activities. For example, if a code fragment contains a bug, we also need to check its clones to fix bugs. Thus, many studies, such as simultaneous modification support and refactoring support for clones, have been conducted so far. Simultaneous modification means modifying clones consistently at the same time. For example, there are two clones. If you modify one clone, you also have to modify its clone. Thus, if clones are modified non-simultaneously, the unmodified code fragment seems to need modification. Refactoring clones means merging clones as a single module, such as a method or a class. In this example, two clones are merged as a new method. And the original places of clones are replaced with statements that call the new method. Thus, if new clones are added, they should be notified developers as soon as possible so that the developers can consider whether or not to refactor the clones. An existing study proposed Clone Notifier, a clone change management system to improve the efficiency of simultaneous clone modification and clone refactoring. Inputs of Clone Notifier are two versions of the target project. Clone Notifier tracks clones between the two versions and classifies tracking results under 4 categories: stable, changed, added, and deleted. Finally, Clone Notifier notifies the developers of the results. Additionally, Clone Notifier is premised on one execution a day. However, we consider this periodical execution has issues. For example, periodical execution delays notifications to developers. This is because even if clones are changed and code fragments get to need modifications, the notifications of the code fragments will be the next execution of Clone Notifier. Besides, periodical execution cannot detect code fragments to be modified before merging branches that contain them into main branch. In the development using a version control system, the main branch should be always bug-free and always ready for release. Thus, in this study, we propose CLIONE modification support system aimed to integrate into development workflow used in the version control system. Our proposed system is named CLIONE. CLIONE is a GitHub bot which supports pull request-based development. Pull request is a GitHub feature which notifies developers of development information and a part of development workflow. For example, in PR-based development, developers fix bugs or add features on not the main branch, but topic branches. Once the developers have done the work, they create PRs and notify other developers of the change information. CLIONE is easy to install on your GitHub projects, and it tracks clones and detects code fragments to be modified at the time of creating PRs. Additionally, CLIONE notifies the developers of the detection results as PR comments. This is an overview of CLIONE. CLIONE is implemented as a server-side application. In this overview, these blue lines mean processes that CLIONE does. First, developers who want to use CLIONE have to register their GitHub accounts and repositories with CLIONE. This registration is required only once. After this registration, CLIONE is executed at the time of creating PRs. When the developer creates a PR, CLIONE downloads the project by git clone. Next, CLIONE detects clone sets from the head commit and the base commit of the PR, respectively. In this example, the head commits are here and here, and the base commits are here and here. Then, CLIONE tracks clones and classifies the clone changes to detect code fragments to be modified. Finally, CLIONE sends code fragments to be modified as PR comments, and GitHub notifies the developers of the results. This is an overview of CLIONE. I'll show you a demonstration of CLIONE. Here, I prepared two fizzbuzz methods, fizzbuzz1 and fizzbuzz2, and these methods are clones. Now, a developer finds a fault in fizzbuzz1. Here, this value should be 5 or 3, and he fixed it. But he overlooks the same fault in fizzbuzz2 and creates a new PR without noticing it. This is a PR. Then, CLIONE detects the non-simultaneous modification. For example, this is modified method, and this is modified method, and informs him that fizzbuzz2 is unmodified. So he will be able to fix fizzbuzz2 before merging this PR. Additionally, we add 3 improvements for more accurate clone tracking than clone notifier. In this presentation, we describe only one of them due to time limitations. One of our improvements is tracking not only clone instances, but also all code fragments, such as methods or blocks in the project. Clone notifier treats only clone instances, which are code fragments detected as clones, as tracking targets. Therefore, for example, there are 2 methods, main1 and main2, that are clones in an old version, but not clones in a new version because of uninserted statement int c equal 1. In this case, clone notifier cannot track these clones because the 2 methods aren't detected as clones in the new version. As a result, clone notifier classifies this change as clone set deletion. However, This change should be classified as a non-simultaneous modification because only main one method was modified. The developer may overlook this non-simultaneous modification due to clone notifier's improper classification. Therefore, CLIONE tracks not only clone instances, but also code fragments. In this example, CLIONE tracks methods in each version. As a result, even if the methods aren't detected as clones in the new version, CLIONE can detect non-simultaneous modification by tracking methods. Next, I'll explain the evaluation experiments of CLIONE. We conducted 2 experiments. First, to confirm how much clones are modified non-simultaneously in PR-based development, we investigated the proportion of PRs in which clones have been modified non-simultaneously. Second, to confirm how effective are our improvements in clone tracking, we compared the results of CLIONE's clone tracking with clone notifiers 1. We selected 3 OSS, JLB, Day4, and JSON. This is because they are developed in PR-based development on GitHub and often targeted in clone research. In this table, we show the project names, the number of all merged PRs, and the number of target PRs. Here, target PRs mean PRs in which at least a Java file was changed. First, we explain experiment 1. Experiment 1 is an investigation of the proportion of PRs in which clones have been modified non-simultaneously. In this experiment, we manually executed CLIONE on target PRs and checked the results. This table shows the results of experiment 1. In this table, improper PRs means PRs in which clones have been modified non-simultaneously. As a result, we found that all of the target projects include improper PRs, and their proportions were range from 11.9% to 30.4%. Thus, if the project developer had used CLIONE, they could have responded to the improper PRs promptly. Next, experiment 2 is a comparison of the results of CLIONE's clone tracking with clone notifiers 1. We executed both CLIONE and clone notifier on target PRs and manually checked differences between their clone tracking results. As a result, in 35 PRs, 27.5% of improper PRs, CLIONE tracked clones more accurately than clone notifier thanks to the improved code fragment tracking. Through this experiment, we confirmed our improvements in clone tracking is effective. Finally, I'll talk about conclusion and future works of this study. In this study, we developed a new clone modification system, CLIONE, and we evaluated CLIONE through 2 experiments. Currently, CLIONE is publicly available from this URL. If you are interested in CLIONE, let's try it. Our future works are evaluating usefulness of CLIONE for developers and capacitating CLIONE to recommend how to modify clones. That's all. Thank you.
Thank you, Tasuku, for your presentation. Any questions? Does anyone has any question? Well, there seems no question. Thank you again for your presentation. Thank you.
Thank you.
So, our last presenter is his paper's name is Identification of Misleading Location Information in Compilers Error Messages. So let's welcome.
Okay. Hello, everyone. My talk is about identification of misleading location information in compiler diagnosis. Hello.
Is it the full screen? Yeah. So
Hello.
I see your some notes in your.
Oh,
in your
okay.
screen. You can change
Yeah.
a different screen. Okay. Yeah.
Okay. Okay. Hello, everyone. My speaker is about identification of misleading location information in compiler diagnosis. I'm Wang from Beijing Institute of Technology. My talk is composed of 4 parts: problem, solution, evaluation, and conclusion. Okay. For problem, syntax errors. Syntax errors are quite common for various reasons. Developers, especially inexperienced ones, may construct illegal programs that contain these errors, like typing errors, example in the figure. Sometimes developers keep encoding too fast to make careful checking. The problem shown in the figure is caused by lack of a semicolon to end the command, which is quite common through development. And the wrong arguments, which occur when function cannot match the arguments that the caller provides. And undefined symbols. Well, for mainstream IDEs, they provide syntax check to show the error location. They can simplify the bug identification and accelerate the bug fixing. For example, Eclipse. The Eclipse warns the user that the statement needs a semicolon on line 5. A user follows the suggestion and inserts a semicolon on line 5, then the bug is fixed and the response is acquired. Nowadays, the existing compiler testing are divided into 4 parts: construct test programs, test oracle, optimizing test process, and the post process of test results. All of them are based on the correctness of syntax check. But however, syntax check is not always correct. For example, shown in the figure, the compiler gives a warning covering dozens of lines with an unclear advice of misplaced constructs. For an inexperienced one, he or she might check each mark through the 55 lines of code. This huge fixing work may destroy the passion for coding. Therefore, we provide a solution. Our solution based on mutation testing. Mutation testing is a well-studied technique that introduces artificial force to the original program we call C. And then we use a set of syntax rules called mutation operators to introduce simple syntactic changes to the original program and creating many different versions of original program we call the mutant. In our rationale, first, where we mutate the C is just the optimal solution for syntax check, providing in the figure where we delete the keyword return. It's just the best warning line for syntax check. However, based on syntax rules, there are still some acceptable lines can be given a warning. These locations can be predictable based on the mutation operators we use and the mutated positions we use. Therefore, we can, shown in the figure, we can find these lines and number them to number 2 to 5. Well, based on our rationale, now we can provide an overview of our approach. We have sample programs, mutation operators, and mutation location. Here we combine the mutation operators and the mutation locations as a group. We use these elements to generate mutants, and that is making different versions of the seeds. Then we compile the mutants and collect the diagnosis. Next, we analyze the diagnosis and filter out acceptable ones based on mutation operators and locations we choose. We check the misleading location messages and update the parameters on operator location pairs. Well, now let's be more detailed. The mutation generation. The mutation generations are based on 4 elements: operator, location, type, and seed. For seeds, in our approach, Emily randomly picks up a legal program for the given corpus. The corpus including source code of 3 well-known open source applications: Erica, Wika, and Grinda. Then our approach randomly selects a mutation operator. We design a set of 27 mutation operators, especially for the syntax check. Then our approach chooses a location, the mutate population, and based on belonging to 7 kinds of location type. Well, for each resulting compiling results, there are several error diagnoses with different location information. We collect the location information in each diagnosis. Then we analyze this diagnosis. After we use a set of heuristic rules to filter out the false positives, which cannot reveal the bug of syntax check. For example, this piece is constructed by deleting keyword return on line 237. And the warning the compiler gives is located on line 225. That reminds the user of returning a result. It is correct. It is a correct answer, and which in our test is regarded as a false positive. To filter out the similar samples, the heuristic rules is designed as which operator we use, delete a keyword, under what situation, delete, return, and warning on a method declaration line. And for the result, it is a false positive. Well, for the after filling out the false positive, we regard the reminder as suspicious diagnosis. To dealing with this reminder, we use manual check. After manual check, all the samples are divided into two groups for false positives and true positives. For false positives, then we update the heuristic rules. And for true positives, we update the parameters. So what kind of parameters? Well, before mutation, we combine the operator and the location type. Now we stop generating the mutants with this combination. This can prevent producing similar mutants and make the testing more efficient. That's all for our approach. Now we turn to the evaluation part. For evaluation, the first research question is about the facts of the proposed approach. Well, we make our testing on ECG, Eclipse compiler for Java. We totally generate 518,400 mutants. and filter out the false positives with 26 heuristic-based filters. And we finally find 7 categories of bugs. The next table describes the seven categories of misleading location information we discovered in ECG compiler diagnosis. And the right is a distribution of these bugs. Here we take the number 1 and number 2 special strings at the end of program and the missing left brackets in if statement as an example. Well, for special string at the end of programs, this sample is generated by replacing double slashes on line 304 with a person sign. We expect the ECG to point to the last line of the source code as the cause of the syntax error. However, as presented in the figure, the compiler refers to the whole source code as a suspicious code fragment and presents an error mark on the first line of the document, saying syntax error on tokens misplaced constructs. Another example is about the missing left brackets in if statement. We delete the left bracket on line 39. Instead of pointing out directly to the mutated if statement on line 39, the compiler refers to all of the source code within the enclosing if statement from line 33 to line 39 as illegal statements. Well, the research question 2 is about the cost of our approach. We use only 18 hours to generate nearly 520,000 mutants. On average, it takes less than 0.1 second to generate a single mutant. The compilation and automatic analysis on the diagnosis is also time consuming. In total, it takes about 72 hours to compile these mutants and analyze the resulting diagnosis. Well, it takes us around 120 hours to check 500 suspicious diagnoses manually and to construct the filters. Well, now let's make a conclusion. In this paper, we review the problem caused by misleading diagnosis, and we propose a mutation-based approach to identify location information. To the best of our knowledge, it is the first compiler testing approach dedicated to location information in compiler diagnosis. The approach automatically generates potential illegal programs by mutation operators, and the proposed approach identifies suspicious location information by comparing it against the location, the mutation location, and filter out the false positives and or equivalent misleading diagnosis with heuristics. Well, then we've confirmed the 7 categories of incorrect or misleading location information in Eclipse compiler for Java. Okay, that's all for our talk. Thank you very much.
Thank you, Yao Ying, for your presentation. Any questions? Well, so there seems no question. So thank you again for your presentation. That's all our presentations. Thank you the 4 presentators and all of you to join this session, and welcome to join the other sessions at the afternoon. Thank you.
Good afternoon and welcome to everyone. My name is Sajid Anwar and I'm here to present my paper with title A Formal Model for Behavior Tree Based on Context-Free Grammar. And this is outline of my presentation.
Sorry for interruptions. New Year. I think I cannot see the videos.
Okay.
Behavior tree, then I will discuss the second element, the context-free grammar for normal form requirement behavior tree.
Okay.
And after.
So you still cannot to see the screen, right?
Yeah. Yes.
Yeah. Okay. Try.
Good afternoon and welcome to everyone. My name is Sajid Anwar and I'm here to present my paper with title.
Okay. See my screen here. Can you see my screen now?
Yes.
Okay.
Good afternoon and welcome to everyone. My name.
Yeah, we can see the video.
Can you see?
Yes.
Okay, Sajid Anwar, and I'm here to present my course paper with title A Formal Model for Behavior Trees Based on Context-Free Grammar. And this is outline of my presentation. First, I will introduce the problem, then I will discuss the motivation behind this research. After that, I will discuss the first key element of our model, which is a normal form of requirements behavior tree. Then I will discuss the second element, which is the context-free grammar for normal form requirement behavior tree. And after that, I will discuss the case studies to demonstrate the applicability of our proposed model. And finally, I will conclude my presentation with some concluding remarks and some future work research directions. Requirement engineering is one of the important and first phase of software development lifecycle. Okay, and one of the key activity of this phase is to use the semi-formal modeling languages to model a user requirements provided in natural languages. And nowadays, the most common semi-formal modeling language is UML and behavior trees. So behavior tree is not as much old as UML, but it has some benefits over UML. So as this is a brief presentation, so I will not discuss all the benefits. But I would like to mention one of the important benefit that has behavior tree over UML. So in UML, so we have a different diagram to design different aspects of the system. Like we have a use case diagram to design the scope of the system, and we have a sequence diagram to design the interaction between objects that involve in the system. Okay, and we have a class diagram to design the structure of the system. And all these diagrams are drawn directly from natural languages. Okay, but in the behavior tree, only the first diagram, I will discuss the cycle, the behavior tree cycle shortly. Only the first diagram is drawn from natural language, and all the subsequent next diagrams are drawn from previously designed diagrams. So in this way, the problem of natural languages is somehow minimized in behavior tree process as compared to UML. So the process to design these semi-formal models from natural languages is very challenging and error-prone. Why? Because the natural language, first of all, the natural language is very flexible. Okay, and each user has different like a way to describe requirements. Okay, and each user can use a different like a set of vocabulary. Okay, so all these problems make this process very challenging and error-prone. Okay. So this is the standard process to model the software by using a behavior tree. Okay, so we have three domains. We have a problem domain, okay, and in which we have a function requirements. Then we have an analysis domain, and followed by a solution domain. Okay, so here you can see only the first part, which is a requirement behavior tree. The first diagram is drawn from natural language. Okay, and after that, all the next diagrams are drawn from the previously designed diagrams automatically. Okay, so in this way, the problems that we have discussed just in the previous slide of natural languages are somehow minimized in this process. Okay, so in the past, a number of studies have been carried out to address this green circle things. Okay, to formalize this this aspect means once the requirement behavior tree is available, so some studies has been carried out to formalize the integration of requirement behavior tree to form IBT. Okay, and some studies are like conducted to formalize this process to refine the IBT into a design behavior tree and so on. Okay, but the bottleneck of this previous research, the gap in the previous research is the process to design a first diagram, which is a requirement behavior tree from natural languages, is still a search gap, still an open question. How we can formalize this process? Okay, how we can minimize the problems that we have facing by while making a transition from natural languages to the semi-formal languages. Okay, so in this search, we try to address this research gap. Okay, so this is the motivation of our research. Okay, so this now I will discuss the first key element of my research, which is the normal form of requirement behavior tree. Okay, so before discussing this one, normal form, like how we have defined this one, so I would like to discuss the rationale behind this. So why we actually need this one? What's the problem that we are facing in our current research, and how we have addressed in our this research? Okay, so I have taken two requirements of already published case study, which is the O1 system. Okay, so and these are the two requirements, R1 and R4, and this is a corresponding integrated behavior tree for these two requirements. Okay, so if we analyze the first requirement R1, we can see that okay, so we have some system in a state, then some event happens, and the system goes to the state. Okay, so this is we can see this is the normal phenomena we have in our daily life in our software systems. Okay, so whenever we have to apply some events, if we have to perform some action, so it requires that the system should be in a state, some stable state, so that the event can happen. Okay, so whenever the event happens, executed, then it requires that the system should move to the next state. Okay, so this actually phenomena is correctly abide in the first requirement R1, but in requirement 4, so this phenomena is violated. You can see that okay, only the post condition somehow is mentioned, but the precondition is not mentioned in detail as well, and the event is completely missing. Okay, so why I'm saying that the precondition is not mentioned correctly. The reason is, if you will see, the precondition is in two contexts. Okay, whenever the oven is cooking or the door is open, it means the precondition, it can be oven is cooking, it can be door is open. Okay, and then the post condition is the light on the oven will be on. Okay, so this is the first problem, the precondition is not correctly defined. The second is the point of integration of R4 with R1 is not according to this this description. Okay, because this is mentioned, this is designed in the existing research, so that's why I mention it as it. But if I have to integrate this one, so I can integrate it because in the last node, which is overcooking. Okay, because it's mentioned in the text. Okay, so in this way, so this actually involves the domain knowledge of requirement analyst. Okay, so maybe some other person can think that okay, I will not integrate it, I will integrate in the power tube node. Okay, so this involves the domain knowledge. Okay, and this we have some problems. So we can say that okay, this is not a complete requirement, this is not a complete individual requirement, it's not fulfilling the phenomena that we have normally in software development and in our daily life. Okay, so this is not a complete individual requirement. So this is actually the problem that we are trying to address, that we have in our natural language listed requirements, and that we have tried to formalize this formalize the solution of this problem. Okay, so in the existing research of behavior tree, we have two axioms. We have a precondition axiom, we have an integration axiom. So I will not discuss in detail. So we can find in the literature. So here we have introduced the third axiom, which is the inertia axiom. Okay, so what is the inertia axiom? In inertia axiom, we have we say that okay, the system should be in a state before applying the event, and when the event applied, the system should go to another state. Okay, so we can say that okay, as we discussed in the previous slide, so this actually it follows the software engineering principles. Okay, and also our daily life principles, our daily life usage of the systems. Okay, so the conditions, one node of the precondition doesn't mean that it's one node. It can be one node, it can be two node, it can be three node, and so on. But this just represents the abstract structure of the system of the requirement. Okay, so in this way we try to formalize by using this axiom, inertia axiom, we try to formalize this the requirement structure, so that we can get rid of this the problem of that we have discussed just in previous slide. Okay, so okay, so this is the second element of our model, which is a context-free grammar. So context-free grammar is one of the formal grammar in Chomsky hierarchy. Okay, so it has been used to specify generator languages, computer languages, natural languages. Okay, and it also used to specify generator model languages. I have attached some references that has used the context-free grammars to specify or generate or verify UML models. Okay, so this is the standard structure. So we have a start symbol, we have a set of non-terminals, we have a set of terminals, and then we have a set of production rules. Okay, so this is the first production rule we have in our proposed model. So in this production rules, we have used dot to show the connection between different nodes. Okay, so as a start symbol, then we have a condition, FL, EV, so these are the non-terminals. So I will discuss shortly. And then we have this is special symbol, which is inversion symbol. So this is one of the property of behavior trees. So I will not discuss here in detail what is meant by inversion. So it actually requires a lot of time. So this is another rule. We have defined this another non-terminal, which is flow. And okay, and now I will describe these rules with the help of example. So this is the normal structure of any requirement. Okay, so we can say it can be one requirement. It can be part of one requirement. Okay. So it can be three requirements. So we have a condition, we have event, we have conditions. Okay, so it's an abstract structure. So how we can generate or verify the structure from these rules? Okay, so this is okay. So in if we have to specify or verify the structure by using context-free grammars, so we have a different approaches. One is the derivation by rules, and one is the parse tree. So parse tree is definitely a simple one and easy to follow, as it's a pictorial representation. Okay. This is a start symbol, then we have listed all the rules. If we will read it from left to right, we will get this structure. Okay, and these are the other rules of the that we have used in our research. And we have a different like an event, we have a 3D events, and these are the symbols. These are to show the behavior types of each node. Okay, and so on. So I will not discuss these in detail as it's short. Okay, so this is a case study. Now we'll discuss a case study to show the demonstration of our. So these are the two requirements. Okay, and this is the corresponding requirement behavior tree and integrated behavior tree. So we have to generate, we can say the verify the structure. So this is the parse tree by using the rules that we have discussed in the previous two slides. Okay, so if you can see, all the leaves are with the terminals, no non-terminals in the leaves. Okay, so if you read from left to right, so this is the sentence we will generate, and this sentence will generate the equivalent integrated behavior tree that we have in our previous slide. Okay, so this as a conclusion, we have defined a third axiom named Hershey axiom to formalize the translation from the natural language requirements to a requirement behavior tree. Okay, and then we have defined a context-free grammar as a set of production rules to generate or verify a normal form requirement behavior tree. And a case study, we have used one of the case study to exhibit the applicability of our proposed context-free grammar. And the result shows that our proposed CFGA successfully identify a common requirement effects such as incompleteness of requirement. Okay, so if any requirement is incomplete, means any precondition, postcondition, or event is missing. So our model has successfully identified all these requirements defects. Okay, in the future, we plan to extend this model to include some more constructs of behavior tree modeling notations. As in this paper, we have just defined very basic, but we have some other constructs. In the future, we are planning to include that one, and we also plan to perform some empirical validation from by using some industrial case study and from industry experts. Okay, so these are the references. You can find the details of corresponding concepts in these references. Thank you.
Hello, can you please hear me?
Yes.
Yes. First of all, sorry to all of you. Actually, I haven't checked the difference of the Singapore time and Australian time. But actually, I was following the And the stealing time, which was mentioned in my presentation, the schedule, like is a 5 o'clock. So I was actually prepared for the 5 o'clock, but I have just come online to just check like what's going on. So it was my presentation running. So sorry for that. I'm here to answer your questions. If you have any questions, from any of the participants.
Thank you. Let's begin the next presentation. A preliminary study on sensitive information exposure through logging. Hi, are you here?
Yes.
Okay, you can screen your.
So I have to present my paper again?
Yeah.
Oh, okay. I can share my screen.
Oh, sorry. Just no need to present your paper again. Yeah.
Oh, okay.
Because
Okay.
I have played the video, so it's okay. So because there's no question, so we can move on to the next presenter.
Oh, okay. Okay.
Okay.
Thanks much.
Sorry, I can't share my screen.
Okay. Okay, I just make you the host, co-host, right? Yeah. Can you try?
Yes. Can you see my slides?
Yes.
Okay. Hello everyone, I'm Chen from Zhejiang University, China. Today I will give a talk about our recent work on sensitive information exposure through logging. As we all know, logging is a common practice to record runtime information to understand the behaviors of systems and users. And developers manually insert the logging code into the software. Here is an example in Hadoop, which records the node status of Hadoop. However, the prevalence of logging also increases the potential risk of sensitive information exposure. According to the top most dangerous software errors list this year, the sensitive information exposure takes the 33rd place. We also count the number of such vulnerabilities in National Vulnerability Database, and this figure shows the result. We can see that such vulnerabilities is becoming increasingly common. What's more, large-scale online services such as Facebook, GitHub, and Twitter also suffer from such vulnerabilities. For example, Facebook is reported that they log the password of users in plain text, and hundreds of millions of Facebook users are affected by this vulnerability. However, we noticed that previous work mainly focused on designing general methods to detect information exposure, such as static taint analysis and dynamic taint analysis. Existing work mainly focused on the information exposure for Android applications. Therefore, there is a lack of understanding on the real-world vulnerabilities, especially for the information exposure through logging. To fill this gap, we intend to answer following two research questions. First, how exploitable are the vulnerabilities? Second, what are the root causes of the vulnerabilities? Here is the design of our study. As the first step, we collect vulnerabilities in National Vulnerability Database, which is one of the most widely used public databases. As a result, we collect 417 vulnerabilities. To answer the first research question, we first collect the common vulnerability scoring system from NVD. Most specifically, we use two metrics to assess the exploitability. They are attack vector and attack complexity. Besides, we also collect the proof of concept exploits. The POC exploits usually are sample instructions to demonstrate vulnerabilities. As a result, we collect 49 POC exploits. As for the root causes of vulnerabilities, we focus on the vulnerabilities in open source software projects. This table shows the top 10 open source software projects according to the number of associated vulnerabilities. We can see that in our study, there are 143 vulnerabilities in open source software projects. To determine the root causes of these vulnerabilities, we follow the card sorting approach to categorize these vulnerabilities by examining their associated information, such as anniversaries, patches, and issue reports. Here is the result of our study. Let's first look at the exploitability. This figure shows the distribution of exploitability metrics of CVSS. We can see that about 2/3 vulnerabilities can be exploited via the network, which means the attackers do not need to get access to the system physically or locally. Besides, a significant amount of vulnerabilities can be exploited with low complexity. By analyzing the POC exploits, we found that a typical exploit can be divided into 3 steps. First, getting access to devices or systems. Second, retrieving log files from devices and systems. Finally, extracting sensitive information from log files. We also found that there are about half of POC exploits can be used by malicious users and insiders without any expertise to launch attacks. By following the card sorting approach, we divided these vulnerabilities into 7 categories with 2 data states. There are 5 categories related to the data in use state, which means the exposed data are being processed by systems. The rest 2 root causes are related to the data at rest state, which implies that the exposed data are stored in persistent storage. I will explain the first 2 root causes in details. The most common root cause is uncertain data in logging objects. Developers usually adopt whole object logging, which means they make logging calls with direct reference to component objects. However, the actual data in these objects sometimes are uncertain. Therefore, it is difficult for developers to identify the sensitive data in these objects. Most specifically, the actual data in these objects vary in different contexts. Here is an example in OpenStack. The parameter connection data contains configuration to connect storage volume. However, developers are not aware of the parameter sometimes contain the passwords to connect specific storage volumes, so they fail to adopt sanitization. Besides, the actual data in these objects may evolve along with the software. Here is an example in OpenStack. The developers have identified the sensitive data in the HTTP request, and they remove the sensitive data by sanitization. However, there are more types of sensitive data introduced during the software evolution, and they fail to adapt sanitization. Another important root cause is the improper implementation of sanitization. Developers have introduced various sanitization functions, such as reduction and hashing, to prevent the information exposure. However, it is not trivial to implement sanitization functions. On the one hand, the developers sometimes make incorrect assumptions on the input format. On the other hand, the sanitization functions sometimes are incorrectly initialized. Here are the other root cause. I just skipped them in this talk. So what can we learn from our study? As I mentioned above, existing solutions mainly depend on static content analysis or dynamic content analysis, which will detect whether there is a value flow from source functions to sink functions without sanitization. However, our study highlights the weakness of existing solutions. First, developers may fail to adopt or adapt sanitization functions due to the uncertain data in logging objects. Second, sanitization functions sometimes are not implemented correctly. For developers, we suggest that they should take care of the logging statements in software, especially for whole object logging. To achieve this, they can build coding conventions and examine the logging statements during code review. To sum up, we have presented the first attempt to investigate the vulnerabilities that expose sensitive information through logging. In the future, we intend to analyze the patches of these vulnerabilities and study how to assist developers to detect and fix these vulnerabilities more efficiently. Okay, that's all. Thanks.
Okay, any questions? Okay, thank you. We can move to the third presentation. Mahalanobis decision-based integration of suspicious scores for bug localization. Hello, are you here?
Okay, how can I share the slide?
Yeah, you can share your screen.
Okay. Can you see the slide?
Yeah, I can see your screen.
Okay. So I start. Okay, hello everyone. I'm Masano Sato at Ehime University, Japan. So I start my presentation. This is the overview of the presentation. The aim is to establish a lightweight bug localization method. As a result, as a method, we focus on the reasonable integration of bug localization metrics. And we apply the notion of Mahalanobis distance. As a result, and the proposed method could work with almost the same accuracy as the state-of-the-art method and reduced computation time. And this is the outline of the presentation. First, I talk about background and motivation. And this slide shows what is the bug localization. Many bugs may be reported while software evolution and maintenance. However, it is not easy task to locate bug files using the bug reports, and it is called bug localization. Hence, there have been various bug localization methods which aim at locating bug files with a high accuracy. And I explain about error-based bug localization. In recent years, many studies have focused on information retrieval techniques using bug repos and software repositories. So we targeted error-based method in this study. And this image shows examples of error-based bug localization method. A method vectorizes input data and get metrics. And next, it calculates a suspicious score based on their metrics. And finally, we can get ranked files based on their suspiciousness. And Amalgam Plus is one of the most promising error-based bug localization method in recent years. And it uses 5 metrics from different perspectives. So, and this list shows 5 metrics of Amalgam Plus and their perspectives. X1 is elapsed days from the last bug fix commit. X2 is bug report similarity. X3 is bug report source file similarity. X4 is file appearance frequency in the stack trace. And X5 is the reporter is the same or not. And explain about integrating metrics in Amalgam Plus. Amalgam Plus integrates 5 metrics into one suspicious score. And the integration for this expression, xi means isometric value of file f, and wi expresses weight coefficient of isometric. And the image shows about integrating metrics. A source file has 5 metrics, and each weight tuned by genetic algorithms, and it integrated into a suspicious score. Amalgam Plus is a promising method, but it has a challenge. GA's integration may take a long time. For example, it takes 3.5 hours to tune for an OSS, and it would be better to retune whenever the metric test set is updated. This challenge motivated us to propose a lightweight integration method to perform a bug localization as quickly as possible. And next, I talk about the proposed method. This is a basic idea for proposed method. The higher value each of the metric has, the more suspicious the file is. And each metric has different perspective. So we express 5 metrics as a 5-dimensional vector and use a distance measure to integrate the metrics into a single suspicious score. And the image shows 5-dimensional vector space and the distance. The red point is the data and red line is a distance from the origin point. So in this study, we use the Mahalanobis distance, so I explain about it. Each metric has a different perspective, and the Mahalanobis distance considers dispersion and the correlations among them. In this reason, the Mahalanobis distance is reasonable for our scenario. So we use it for the metric integration, and the distance is calculated from this expression. Although the most general distance scale is the Euclidean distance, I explain why we use the Mahalanobis distance. In the graph, green points are data of interest, and each circle is the distance from the origin point. In the Euclidean distance, A1 and H are on the same circles. It means distance A1 and H are same. On the other hand, the Mahalanobis distance considers data correlation. So A1 and H are on the different circle. It means both distance are different. So in this case, the distance of A1 is further than A2 because the dispersion and the correlations are considered. So next, I explain about the empirical study. The study aim is to compare the accuracy and the computation time between amalgam plus and the proposed method. We expect the proposed method can perform much faster than amalgam plus. And we also expect the accuracy at almost the same level as amalgam plus. And this is the evaluation criteria. Regarding the accuracy, we adapt top 1, top 5, and top 10 accuracy. And about the computation time, in GA, the time it takes to choose the weight coefficient in GA to get the suspicious score. And in Mahalanobis distance, the time to integrate 5 metrics to get the suspicious score. So now I explain about examples of the accuracy evaluation. In the case of top 1, suppose the following files are recommended for bug repos, and the third and seventh file are actually modified. In the case of top 1, interest or rank of 5. In this case, no modifications in the source files within the range of top 1. It means bug locate failed. Then I consider another example in the case of top 5. As well as top 1 case, suppose the third and seventh files were actually modified. In the case of top 5, it interest within rank 5. So in this case, there's modified file within the range of top 5. It means bug locate succeed. In the case of top 1 is also same. So as the dataset with the 6 OSS project, and we is a part of the dataset provided by Russ and Patrick, and obtain software repositories from GitHub. So I show the story result about part of the accuracy. In the figure, the blue bars represent the accuracy of amalgam plus, and red bars represent the accuracy of the proposed method. In Rail project, the proposed method improved the accuracy about top 5 and top 10 cases. In Spike project, no accuracy improved by the proposed method. And the result shows that the proposed method does not outperform amalgam plus, but it shows almost the same accuracy as amalgam plus. And I showed another result about the part of the computation time. In the figure, blue bar represents the computation time of amalgam plus, and red one represents the computation time of the proposed method. In Rail project, the proposed method reduced the computation time about 98%, and also in Spike project, the proposed method reduced the computation time almost 98%. And totally, the proposed method could reduce the computation time by about 97% on average. So I discussed about the result. The proposed method works well, even though it does not need any parameter tuning. It showed almost the same accuracy as amalgam plus, and the computation time was reduced by 97%. Because Mahalanobis distance can evaluate the multidimensional distance reasonably, it might be useful for the metric integration as well. We think this is an advantage of the proposed method. However, there can be a risk of decreasing the bug localization accuracy if we use a user's metric. On the other hand, GA is a supervised running method and can minimize such a risk. And this is a threat to validity. As construct validity, the parameter setting of GA would affect the computational result. And as external validity, we used only 6 Java projects, and the proposed method may not work well for another project. So we would also need to perform further study using various projects. And finally, I talk about conclusion and future work. As the conclusion, firstly, we proposed Mahalanobis distance-based integration method instead of GA-based one for bug localization. And secondly, the study results show the proposed method can reduce the computation time. It reduced 97% on average. And finally, the empirical result did not show severe deterioration in accuracy of the proposed method. And about future work, we need to enhance the accuracy of the proposed method through a further study on the contribution of each metric for bug localization. And we think a further comparative study using various methods other than amalgam Perf needed. That's overall my presentation. Thank you very much.
Okay, thank you. Any questions? Okay, thank you. Maybe we can move to the next presentation. Okay, thank you. Yeah, are you here? Can you share your screen?
So I am not unable to share my screen.
Yeah.
Okay, you can try it now.
Still, I am not able to share the screen. The message I get is host disable participation screen sharing.
Okay, I just made you a host. You can try now.
Yes. Are you able to see this? Are you able to see the screen?
No, I think no.
Now?
Yeah, I can see it. It's
Okay.
fine now.
Okay, good afternoon, everyone. My name is Puneet Bhateja. I am from India, and the topic of my talk is asynchronous test equivalence for probabilistic processes. In theoretical computer science, a label transition system is often used to model the operational semantics of a concurrent process. A label transition system can be formally defined as a tuple P, which consists of a set of states denoted by capital Q, a set of actions denoted by sigma, a set of transitions denoted by right arrow, and a distinguished initial state denoted by Q naught. A notion of semantic equivalence can thus be defined as a binary relation over the universal set of label transition systems. Language equivalence, bisimulation, isomorphism, etc. are some of the well-known notions of semantic equivalence, each defined as a binary relation over the set of all label transition systems. A common feature among these notions is that they all are characterized by the intentional behavior of a process. In 1984, Italian computer scientist Rocco Di Nicola, along with his PhD supervisor Matthew Hennessy, suggested that semantic equivalence can also be characterized by the observed behavior of a process. In simple words, two processes are deemed equivalent if they cannot be distinguished by an observer or a tester interacting with them. The behavior of a process as seen by the tester is called test behavior. Now, the interaction between the process and the tester can be synchronous or asynchronous. In synchronous testing, the two interact with each other by doing common actions simultaneously, whereas in asynchronous testing, they interact with each other through a medium. And this medium is generally modeled by a pair of first in, first out queues. So here is our setup. What you see on the screen is a probabilistic process, which is separated from its environment by a medium. The medium is depicted by a pair of first in, first out queues. We are here interested in the test behavior of a probabilistic process, which is observed asynchronously through a pair of queues, the input queue and the output queue. Now, what is input queue for the process is output queue for the observer and vice versa. Each action of probabilistic process is either an input action or an output action. In other words, the set of action is partitioned into input actions and output actions. This partitioning helps modeling of systems which are reactive in nature. Each action in a state happens with a certain probability. As you could see, the top state has two transitions emanating from it, each with probability 0.5. So the sum of the probabilities of all the transitions emanating from a state should therefore be 1. So here is an example of a asynchronous test behavior of a probabilistic process. It is denoted by the set ATB of P. It has 3 elements. The first element is a triple, which is A, epsilon, 05. Now let me explain how we arrive at this. The top state can do A or another array. It does first A with probability 0.5 and thereafter it doesn't do anything. But if it does right A, it could follow by X or Y. So the behavior is A, X 0.25, 0.25 because 0.5 into 0.5 is 0.25. And likewise, you have A, Y, 0.25. So these 3 triples, they constitute the asynchronous test behavior of a probabilistic process P. So that was the informal definition of a probabilistic process. So here is a formal definition also. When you are given a probabilistic automata with inputs and output, which I said earlier is a tuple having 4 parts, its asynchronous test behavior is a set of triples u, v, phi, such that the following conditions hold simultaneously. The first condition says that there must exist a path from the initial state to another state q, and that q should be deadlocked. From deadlock, I mean that there shouldn't be any output action emanating from that particular state. And now this path is labeled by w, p, which means that W is the sequence of actions that one does and P is the probability. Now, if W is projected onto input alphabet, you get U, and when W is projected onto the output alphabet, you get V. And the second condition says that if there are multiple such paths from Q0 to states Qj, then all those paths in P should be such that Qj is the deadlocked and Wj when projected onto the input should be equal to U, and Wj when projected onto the output alphabet should be equal to V. And the sum of the all the probabilities should come out to be phi. So this is the formal definition. And the one that I stated on the previous slide is an informal definition with an example. So now we have a notion of asynchronous test behavior equivalence. which means that there are two processes P1 and P2, and they are exhibiting the same asynchronous test behavior. Here is an example. So what you see on the screen are two processes, namely P1 and P2. So their asynchronous test behavior is the same, which is equal to a comma xz comma 0.5. This is first triple, and the second triple being a comma xy comma 0.5. As you could see that these two processes are not equivalent through traces. For example, the first process does AXAY, which the second one doesn't do. And likewise, the second one does AAXY, which the first one doesn't do. So that was all. Let me conclude at the last. We have proposed a notion of semantic equivalence over probabilistic processes, and we call it asynchronous test equivalence for the reason that this equivalence is determined by a tester, which it interacts asynchronously with the processes. Next, we have compared our notion with the existing notions of semantic equivalence over probabilistic processes, and we have found that our equivalence does not bear any relation with the existing notions of test equivalence. It still remains to be investigated whether the problem of determining this equivalence is a decidable problem or not. In case it is undecidable, we need to come out with a strict mathematical proof of undecidability. And in case it is decidable, then we need to establish its complexity. That was all from my side. Thank you so much. Any questions?
Yes, thank you. Any questions? Okay, thank you. It seems no questions. Let's have a short break.
Thank you so much.
Yes, thank you.
Good afternoon, everybody. My name is.
Can you see my screen now?
Yes.
Siddharth, and I'm doing my master's at NUS in Singapore.
And my name is Saurabh, and I'm also doing my master's at NUS.
And we will be co-presenting our paper titled Model-Driven Inputs to Aid Athletes' Decision-Making in the Field of Soccer. Let us look at why it is important for athletes to make the right decision during a game of soccer. Let us first look at this graphic, which is showing a scenario wherein there are two teams. The team shown in red is the team that has possession of the football, and they are trying to score from right to left. And there is a team shown in yellow, which is trying to defend their goal on the left-hand side. So the sequence here shows two passes followed by a shot by the third player, which leads to a goal being scored. Now let us look at a second scenario wherein there are again two teams shown in red and in yellow, and the same person has the ball as compared to scenario 1. But in scenario 2, the player chooses to make a different set of passes. But in the third step, the ball again ends up with the same player. This player again attempts a shot on goal, but this time his shot is blocked. So let us look at how are these two scenarios different. Firstly, they are different because of the fact that one of them led to a goal and one of them did not lead to a goal, and also because of the fact that the preceding steps to the goal were a different sequence of passes in the first scenario compared to the second scenario. Now if we were to look at only the third step in isolation, you can see that in the first scenario the player had more space to take a shot and it led to a goal being scored, while in the second scenario the player didn't have adequate space, and so when he took his shot was blocked. But if we were to just look at this decision of the player itself, we find that this decision alone is not really a bad decision taken by the player. But we also find that the preceding passes before this shot was taken might have also led to the player in possession not having adequate space to take a shot on goal. We can conclude from this slide that making individual good decisions does not necessarily guarantee the best outcome for that scenario, but rather soccer is a sport where a sequence of good decisions by players on the same team leads to the team in possession scoring a goal. So now let us look at what is our problem statement. Our problem statement is divided into two main aspects. The first is to model the game of soccer as a domain-specific sequential model. And the second part of problem statement is to create a value function that is able to assign a value to every state that can occur in the game of soccer and then recommend what is the best action or decision to take at every step of the sequence in order to maximize the probability of scoring a goal. The different possible actions that may be recommended can either be a pass to any of the other teammates, a dribble to another better area on the pitch, or taking a direct shot on goal. Until now, we looked at the problem statement. So now let us look at what is the methodology that we will be using in order to solve this problem. So first, we look at the different possible next actions that a player can take, which could be a dribble, a pass, or a direct shot, and then use data-driven approaches in order to assess which amongst these is the best and choose that to be the best next action that the player must take. Apart from the next decision that a player must take, we also explore sequences of actions that might never have occurred during a game of football, but that might have the probability of maximizing the chance of scoring a goal. This is done through a model-driven approach.
Now we take a look at the first step of the methodology, which involves creating 3 domain-specific action success models, which is modeled using MLP. There are 3 action success models that are created for each of the on-the-ball actions, namely shot, pass, and dribble, and these models are capable of predicting the probability of each of these actions being successful. So to start off with the first model, we take a look at the expected goals model, which is created to evaluate the probability of success of a shot. So the image shows a domain-specific design for the XG model. So the input features for this model is divided into 3 parts. The first represents the spatial features, which is denoted by the distance on goal and the angle made between the goal post. The second is the personal attributes, which talk about the individual capabilities of all the players that are involved in the shot, whether they are offensive or defensive. And the third involves the additional situational features which led to the origin of the shot. The XG model that we saw in the previous slide is not a new metric. So from the table that we see in the slide, the first column indicates the year in which the competition was played, followed by the competition itself. StatsBomb, which is a sports analytics company, has released data for all event sequences that occurred in these years. This data was basically used for validation of our XG model, where it was compared with the StatsBomb XG model. The first column in the table talks about the actual number of goals scored from all the shots taken on goal. The second column indicates the predicted XG by the StatsBomb XG model, and the final indicates the predicted number of goals that should have been scored by our model. As you can see, for 10 of the 13 years, the model that was created for this paper was able to give a more superior prediction, which was closer to the actual number of goals scored. So next we move on and take a look at the pass completion model. For the sake of this model, the pitch was divided into 38 zones, as we can see in the image. The defensive zones are less dense, whereas the offensive zones are more dense, as there are more number of actions that are taking place in the offensive zones. Similar to the shot model, the pass model also has 3 sets of inputs. So the first of which is again the spatial features, which are defined by the start and end location of the pass and all the other players involved. The second talks about personal attributes of each of the individual players that are involved in the pass. And the third is again the situational features, which talk about the origin of the pass. And finally, we take a look at the third and final model, which is the dribble completion model. So the image again shows domain-specific interpretation of the dribble completion model. The input features for this, again like the previous 2 models, is divided into 3 parts. The first of which is the spatial features, the second of which is the situational features, and the last of which is the personalized features. So next we take a look at the second part of our methodology, which involves analyzing a sequence of actions. So in order to do this, we have modeled our use case as a Markov decision problem, or an MDP problem. So every MDP consists of a tuple, which consists of a set of states, a set of actions, a transition function, and a reward function. As we have seen before, the pitch has already been divided into 38 zones, and in our case a state is defined by the zone in which the player in position currently is, all the zones of his teammates, and all the zones in which the opposition defenders are present, along with the play pattern and whether the person performing the action is under pressure. Secondly, we move on to the set of actions, which is defined by the pass, dribble, and shoot action. Thirdly is the transition function, which basically talks about the transition probability from one state to another upon performing a particular action. And finally is the reward function, which in our case has a value of +1 for when a goal is scored and -1 for when the opposition gains possession of the ball, and has a value of 0 for all other intermediate states. So in order to solve an MDP, firstly we require a function which relates a state with an action. So the reason for this is so that we are able to figure out what the best action to take at any given state is. So as we can see on the slide is the definition of the value function, which is basically evaluating the best action to take between a shot, which is represented by XG, a pass that is represented by PC, and a dribble that is represented by DC. And this function is used in order to find the most optimal action to take at that state A out of the 3, which has the maximum probability of ending up in a goal.
So now that we have looked at the formula for the value function, let us try and look at how good the value function is predicting actions in actual games. So in this first sequence of events, we will be looking at a match between Levante and Barcelona. So this is a sequence of events that lead to goal. So in this first sequence of events, the action taken by the player is the same as the action that is predicted by our model. Going to the next sequence of events, we again see that a through ball was made by the player in possession of the ball, which is again same as the action that is predicted by our model for the same scenario. And in the third step, with the goalkeeper not in his actual position, the model predicted taking a shot on goal, which was again the same as the action that was taken by the player, and it led to a goal being scored by the team in possession. Now let us look at the second sequence of events. This is a sequence of events that does not lead to a goal. So in this first step, we will look at the team in possession where our prediction is a pass to a different player as indicated by the yellow arrow instead of the actual action. This action is slightly different from the actual action made by the player, but considering the fact that it is a pass made to a slightly forward area and both the players are in close proximity to each other, it is still quite a comparable action. Now looking at the second sequence, we see that again in this sequence, the player performs the same action as that predicted by our model for this scenario. But in the third step, the player decides to take a shot on goal and the shot is saved by the goalkeeper. But for this exact same scenario, our model predicts a pass that is made indicated by the yellow arrow. So this is because of the fact that for the player in possession, the angle to goal is slightly narrow, and if he were to make a pass as indicated by the yellow arrow, the next player will have a much wider angle to score from. Next, we evaluate our value function by comparing the predictions made by our model in various scenarios that occur during a match to the actions that are performed by the players in those exact same scenarios, and try and look at how much our predictions concur with those decisions that were made by the players. One of the limitations that we have is that we do not exactly know what might be the intention of the player when he's taking a certain action or making a certain decision during the course of a game. We assume that every time the player makes a decision, it is in order to maximize scoring a goal. And we also find that our model is able to make reasonable predictions even with limited knowledge as to what might be the actual intention behind making certain actions on the pitch. In conclusion, based on our problem statement, we were successfully able to create domain-specific designs to model the different on-the-ball actions in the game of soccer, which were pass, dribble, and shoot. Secondly, we were also able to create a model-driven value function that was capable of predicting the best sequence of decisions that the team in possession of the ball must take in order to maximize the probability of scoring a goal. With that, we would like to end our presentation, and we hope you liked our presentation, and if you have any questions, we would be happy to answer. Thank you.
Okay, thank you for the sharing. Does anyone has questions to ask? We have the author here right now. Okay, I have one question for the author. Is the author here? Can you hear me?
Yeah.
Okay. Okay. In your videos, I think you model this problem as an MDP problem. And my question is, do you use any learning algorithms to learn the policy to play the soccer game, like maybe reinforcement learning or other learning algorithms?
Yeah, we do use reinforcement learning in order to learn the value function and the policy function.
Okay, so one of the slides in your videos, you show that you use the maybe the value function you learn to predict which is the best action to take. And in your videos, I saw you use the YouTube image as a demonstration. My question is that you need a simulation to learn the policy, right?
So we use something called as value iteration.
Iteration. Okay.
Yeah. So I mean, basically, for the in the game of football, there are when you look at a match, there might be a single pass or a single dribble or a shot that might be actually recorded over the course of a game, but there are, for that same scenario, there are 10 other passes or so many other dribbles possible, which are not actually recorded. So, I mean, the reason for us using reinforcement learning is that we are trying to explore those sequences of play during the game, which have never actually been recorded, and to look at how, I mean, threatening or how much they could possibly lead to a goal being scored by the team in possession of the ball. And I mean, that is how we utilize reinforcement learning, and then we utilize value iteration in order to find the value of the states and to come to a value which is acceptable after a certain number of iterations.
Okay, I see. Thank you for the answers.
Thank
Okay.
you for your question.
If no more questions, let's move into the next paper. Our second paper is an attentive deep supervision-based semantic matching framework for tag recommendation in software information sites. And are the authors here? Are the authors here? If no, we will play the videos instead. Okay. Hello, Liu Ye. Can you help with playing the video?
Okay, try again. See. You see my screen now?
Yeah, we can see the screen, but we cannot see the video.
Can you see the video now?
Nope.
Yes, sorry. Sorry. Can you see the video now? But see the screen now.
Yeah, I can see the screens.
Okay, let's try to play the video.
Seems.
Can you see my video?
No.
No? Okay, let me check. What's the problem? Okay. Can you see my screen now? Okay. Is that fine? Jan?
1 second. I think the authors are here. Okay, so hello. Can you? Are you going to give us a presentation? The author for the second paper. Okay, you can. Let me give you the permissions. Okay, maybe Liu Ye, can you give him the sharing
user? Okay. Okay.
Okay, go ahead. You are mute. Hello?
Hello.
Okay, we can start.
Can I play the video?
Sure.
Okay, I can try again, but I'm not sure what's.
Can you see the well?
Yeah, we can see the slides.
Sorry, I can see the slides, but I didn't hear any voice. Okay.
What about now?
No. Okay, let me try. I try myself. Yeah, I try myself. Yeah, to play your video in my desk, in my laptop. Okay.
Oh yeah, yes. Good afternoon.
Can you see my video here?
Yes.
Okay.
Everyone, I'm Zheng Xinghao, and I am from Wuhan University of Technology. Today, I will present our paper, an attentive deep supervision-based semantic matching framework for tag recommendation in software information sites. The paper is divided into the following 4 parts. The part 1, Introduction. Nowadays, tag recommendation studies become hot topics and receive extensive attention from various fields because software information sites provide software developers resources to communicate around the world, such as following papers. In addition, a software information site usually requires developers to classify software objects with multiple tags when posting. High-quality tags are expected to be concise and can describe the most important features of the software objects. However, most of the existing methods regard tag recommendation as a multi-label classification task, which regard tags as labels. This leads to 2 problems. 1. Excessive abstract semantic features learned by the model at the top of layers and the large loss of shallow features. 2. The semantic information of tag is not taken into account. The main existing methods are as follows. They all use multi-label classification methods without considering the semantic information of the tag. In our paper, the tag recommendation task is viewed as a sentence pairs classification task to better take into account the semantic information of the tag. Besides, an attentive deep supervision-based semantic matching framework is proposed, contributing to the multi-scale semantic features, and different encoders of BERT encode a rich hierarchy of linguistic information.
Okay, I see some problem with the video. Let's play again, okay? Yeah.
Yeah.
Can you see my video
Yes, yes. You can see now.
perfect or not?
Yeah,
Is
it's
it
okay.
okay?
Yes.
So I'm sorry about that.
Good afternoon, everyone. I'm Zheng Hao, and I am from Wuhan University of Technology. Today, I will present our paper, an attentive deep supervision-based semantic matching framework for target recommendation in software information sites. The paper is divided into the following 4 parts. The part 1, Introduction. Nowadays, target recommendation studies become hot topics and receive extensive attention from various fields because software information sites provide software developers results to communicate around the world, such as following papers. In addition, a software information site usually requires developers to classify software objects with multiple tags when posting. High-quality tags are expected to be concise and can describe the most important features of the software objects. However, most of the existing methods regard target recommendation as a multi-label classification task, which regard tags as labels. This leads to 2 problems. 1. Excessive abstract semantic features learned by the model at the top of layers and the large loss of shallow features. 2. The semantic information of tag is not taken into account. The main existing methods are as follows. They all use multi-label classification methods without considering the semantic information of the tag. In our paper, the tag recommendation task is viewed as a sentence pairs classification task to better take into account the semantic information of the tag. Besides, an attentive deep supervision-based semantic matching framework is proposed, contributing to the multi-scale semantic features, and different encoders of BERT encode a rich hierarchy of linguistic information. Next, I will introduce our framework. The overall proposed framework is shown in Figure 2, which contains 3 layers. In embedding layer, the hidden state of nth layer can be computed to equation 4. And in attentive deep supervision layer, the third semantic feature representation XO can be described by equation 7. By considering the attentive deep supervision, the features of different levels of abstraction can be captured better. In matching computation layer, XO is fed into a fully collected layer for matching computation. After that, softmax function is utilized to calculate confidence probability of each tag, giving an object description. The objective function of our framework is based on Crow interface function. And part 3, experiments. The effectiveness of tag metric is evaluated on the 4 software information sites, are the same with tag deep break. They are stack overflow, ask different, Unix, and free code. And 3 widely utilized evaluation metrics are employed. Top K recommendation recall, and top K recommendation precision, and top K recommendation FE score. Then, to prove the validity of our tag metric, we choose the following approaches as baseline for comparison. Tag deep break. Attention-based BILSTM is proposed to capture deep potential semantic meaning, which is one of the state-of-the-art approaches so far. Fast tag break. It applies fast text multi-label classification method to tag recommendation in software information sites, which is the state-of-the-art approach before tag deep break is reported. We show the performance of our framework against the baselines in Type 2. The bold fault in the table indicates the best result. Experimental results show that our tag metric has achieved better performance compared with the state-of-the-art approaches. And we showed observation studies in tables 3 and 4. The experiments also demonstrate the validity of our proposed sentence for classification and attentive deep supervisions. Finally, conclusion and future work. In this paper, an attentive deep supervision-based matching framework called tag metric is proposed for tag recommendation. It changes the traditional way based on classification to pairwise matching learn approach, which targets at making good use of the semantic information of tags and objects. Extensive experimental results on 4 public datasets show that our framework is much better than the 2 popular baselines. In the future, code information will be taken into account in our framework. That's all. Thanks.
Okay, thank you for the sharing. Does anybody has questions? Okay, I have a small question for the authors. Are you here? Can you hear me? Are you here, Xin Hao? Okay, you are muted.
I'm here.
The proposed method, can you use it in the web domains to explain the code like HTML tag? Can you use it?
Use HTML tag.
Yes.
What you mean?
I mean, can you, if given a HTML code, Can the proposed method to match the HTML tag to maybe some object like button or input or some widget, some other widget?
No. The purpose of our framework is to recommendate the tag for objects on software information sites like Stack Overflow. Its objects contains. Right now we have no use. We have no use of the code. We will consider the code information in our future work.
Okay, I see. Okay, thank you for your answers.
Thank you.
Does anybody has more questions? If no, let's moving to the next paper, which is ORI, a gray box fuzzer for some IP protocols in automotive Ethernet. Is Yuekang here? Yeah. Okay.
Yes, I'm here.
Can you
share
make him the co-host so that he can share the screen?
Okay, so which one?
Okay.
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 So can you see my screen?
Yes.
Yeah.
Okay. Good afternoon, everyone. This is Yuekang Li from Nanyang Technological University. And actually, today I'm going to present you our work, ORI, a gray box fuzzer for some IP protocols in automotive Ethernet. So this is a joint work between NTU and Continental Singapore. So this is the overview for today's presentation. First, I will introduce you some background about our work. Next, I will introduce the motivation of doing this work and also the challenges when doing this work. And after that, I will introduce you our approach to address the challenges. And after that, I will talk something about the implementation of a prototype for this approach and some basic evaluations. Last but not least, I will introduce some future work because this is an early research achievement. So we have still a long way to go. So first, let me talk about what is some IP. When you see the title, you may wonder what is some IP. So some IP is actually a lightweight protocol widely used in the automotive industry. Actually, nowadays we can see that in our cars, there are a lot of different sensors, and each of these sensors actually, when they collect data, they need to communicate with the other sensors to combine the information and for further processing. So how do they communicate with each other? So then they need to use some protocol, right? So the most widely adopted protocol nowadays is some IP, and some IP is as we can see, it's in the application layer of the network, and it is mostly on top of TCP or UDP. And although some IP is is a lightweight protocol, it supports both procedural calls and event notifications, which means that the client can send requests and get responses from the server, as well as subscribe to some services and get notifications. So if you look into the detail of how the client and server communicates with each other based on some IP, we can see that the protocol itself is actually very simple. So if we don't consider the situation of subscription and notification, then the situation is very clear. The client just send a request to the server just process it and gives the client a response. And although it is very simple, it is SOMIP is still very capable because it can do almost anything, and it is widely used in the automotive industry. The format of the header, because when we send the request, right, we are actually sending the packets. So the format of the header of the packet is very compact, as we can see in this figure. It is very compact and very informative, because you can see that when the client sends the request, it will indicate the service ID, the whole length of this packet, the request ID is or the protocol version, the interface version, message type, and so on. And besides the header, there's a payload in this packet. The payload of the packet could be anything. It is just some raw information for the other side to precise ways. So as we can see, SOMIP is a very simple but very capable protocol. So now let's look into what is fuzzing or fuzz testing. So because we are doing fuzzing for SOMIP protocol, right? So now let's look into what is fuzzing. So fuzzing or fuzz testing is actually a software testing technique for vulnerability detection. And the basic idea of fuzzing is also very straightforward. The basic idea is we execute the program with a large amount of randomly generated inputs, and then because we are executing the program, we can observe the behaviors of the program, right? So when we observe the behavior of the program, we observe for abnormal behaviors like crashes or some unexpected exit status. If there's a crash, it may have some vulnerability. It may have some indication for security issues, because some crashes are due to the memory usage violations, such as write out of bound for an array. Then in that case, the attacker can try to exploit that vulnerability. So we observe abnormal behaviors, and these abnormal behaviors may have security indications. And this is the basic idea of fuzzing. But if we just do this very simple fuzzing, it's not very effective, because every time we run this program, we just use a randomly generated input. And after the program exits, we just observe for the crash or the exit code. We are not getting any execution information of this program. To make fuzzing more effective, nowadays people are applying gray box fuzzing, which is we not only execute the original program, but also instrument the program. By instrument, we mean we add some additional code to the original program, so that we can collect execution information such as code coverage during of the target program. So in this case, we can use the collected execution information to help us to guide the mutation and to keep the interesting input as new seed to further generate test inputs. In this case, where the gray box fuzzer can explore the program step by step. So this is gray box fuzzing. And as we know, as we have shown in the background, we can use gray box fuzzing to find vulnerabilities. And SOMIP is a very interesting target, actually, because SOMIP is widely used in automotive industry. However, it is not well tested, because currently there's no applicable testing techniques for SOMIP protocol. Why? It seems very simple, right? But why but why it is very hard to test? Because server-like programs are very hard to test. So first, it is if we want to make our test scalable, the first thing comes into our mind is that we can apply multiple file instances to run in parallel. So we can fully use the computational power of the device, right? But it is not possible to run multiple instances of the same server on the same device. On the same device. This is because the server program may occupy some unique resource of the device, like the port or some files that are locked. So it is hard to perform parallel fuzzing on server-like programs. And the second problem is the server is always running. We can hardly observe for the exit status of the server because it is always running. It keeps running there. And the third problem is that although this communication between the client and server is very simple, the packet of the SOM IP protocol is not that simple as shown in the previous slide. We can see that there are different fields in the header of the packet. If we do random mutation, if we just mutate the header randomly, we can see that we will generate mostly invalid packets, and we cannot test deep into the server. So the parallel fuzzing and the low efficiency of random mutation are the two main issues here. So to address these two issues, we propose an approach named ORI. So ORI is actually the name of a game character, and this character is a protector of the forest. And we hope that with our tool we can protect the automotive software. So we name it as ORI. And to address the previous two challenges, we propose two strategies. The first is attach fuzzing mode. The second is structural mutation. So this is an overview of the structure of ORI's approach. So first, because we are doing the gray box fuzzing, we need to instrument the program as mentioned before. So first, we need to instrument the program, the original program, and then, unlike previous gray box fuzzers, because in previous gray box fuzzers, the life cycle of the target program is managed by the fuzzer. Instead of doing that, because we want to run the multiple servers in parallel, multiple test instances in parallel, we are trying to separate the logic between, we are trying to separate the life cycle handling out of the fuzzer's logic. So in this case, in ORI, the original program or the test target can run independently, and after it starts, it will run into a state called fuzzing server, because we instrumented some code right into the original program. So it runs into the state called as fuzzing server, and this fuzzing server can fork new test processes for the fuzzer to fuzz with, to play with. In this case, if we inject the fuzz server after the original target has acquired the unique resource, then we avoid the conflict between those unique resources. Imagine the case of the server. After the server has occupied a port, then we let it run into the fuzzing server state. After that, we can fork new instances of the same process for us to test with. In this case, all these new test processes are still using the same port. There's no conflict, and we can fuzz it. We can run multiple instances of the fuzzer. In this case, we can deal with the problem of parallel fuzzing. For structural mutation, when we generate the test input, we give the further awareness about how the header should be built, how the header should be built, and we randomly mutate only the payload. And in this way, we can effectively test the deep logic inside the server program. So now let's look into the detail of how the fuzzer communicates with the test target. So this is a workflow of ORI. I won't introduce every detail of this graph here. I will briefly introduce some key components or some key steps in the workflow. So first, unlike previous gray box fuzzers, our target and fuzzer can run independently. So first, the target we can start the server. And because we have instrumented the fork server logic into the original program, so it will run into our injected code, and it will start to wait for the fuzzer to connect to connect. And then we can start the fuzzer. The fuzzer will set up the shared memory. This shared memory is used to hold the execution traces of the target, and then it will start to set up some pipe connections and try to communicate with the target. Once we have done with the setup, we can once we have done with the setup, the fuzzer will inform the target, saying that okay, I'm ready. You can continue your execution. Then the target will connect to the shared memory because it needs to log the execution trace, and then it will inform the fuzzer, okay, I have connected, and then it will start to wait again. And in this case, and then the fuzzer can start to ask our test target to fork for new processes for us to test with. In this case, the fuzzer will just say that, okay, you can fork a new instance for me to test with, and then after the target has received this request from the fuzzer, it will fork a new instance, and then it will inform back to the fuzzer. The fuzzer then will prepare a new SUMIP packet. In this preparation of this new packet, it is not randomly prepared. It is based on some structural information, and then it will send it to the target to process. And after the target has ended processing this packet, it will just inform back to the fuzzer, and the fuzzer will just acquire the test result, like the code execution trace, and observe for those behaviors, like we mentioned before. So this is a basic workflow of ORI, and we have implemented ORI as a prototype, and the fuzzer side is implemented in Python, around 400 lines of Python code, and we use the Scapy library to help us to generate valid SUMIP packets. And for instrumentation part, we modified the AFL's LLVM mod, and the modification involves around 200 lines of code. And for our evaluation target, because SUMIP is, although it is widely used, it is rarely publicly available because most automotive industry companies, they won't open source their code. So for our evaluation, we found only one open source SUMIP project, which is called vSUMIP, and we just modified the test example of that repository and do some very basic evaluation. So we found that okay, the execution speed in our experiment is that we can perform 1 or 2 tests per second, and we also found that our structural mutation is very effective because we manually inject a crash of the server. We can find the crash with structural mutation in 5 or 6 seconds, but we can never trigger the crash without structural mutation, or only with random mutation we can never find the crash. And as for future work, we are planning to fast more real-world applications because, as you can see, we only tested on the WSUMIP framework. And we also plan to improve ORA's effectiveness on multi-threaded programs because we found during our experiment, we found that most of the WSUMIP servers are multi-threaded programs, and there are some issues when we are doing that. And we also plan to extend ORA to support more automotive protocols. This is because SUMIP, although it is widely used, it is not dominating the market. So there are still some other automotive protocols to be applied to. And that's all for my presentation, and thank you for your time.
Thank you very much. Does anyone has questions?
Hi, I have a question. You said that your future work is want to extend the further into more automotive protocols. So do you think it is possible to support some protocols that is non-automotive, some general protocols?
This is an interesting question. Thank you for your question. And we are planning, in theory, we can apply the techniques to other protocols, not only automotive protocols, but in our tool, we don't handle the complex state of the protocols like TCP. They have some handshakes, right? So we don't handle the complex states. But the idea of the attached mod and structural mutation could be applied.
Okay, thank you.
Okay, thank you for the answers. Is there any more questions? Okay, let's move to our last paper, which is automated assessment of collaborative software engineering development process. Is the author here?
Yes, I'm here.
Okay, are you going to sharing the screen?
Yes.
Okay, Liu Ye, please give her the permissions. Okay.
Okay. Hello, everyone. I'm so glad to have this opportunity to introduce our research topic, automated assignment and evaluation of contribution of collaborative software engineering development process. This is a catalog and at first introduction. A software engineering project developed around user needs. The development process is divided into project start and rapid iterative development. Students participating in the project needs to do are discussion, planning, design, programming, and testing, and so on. Instead of working overtime a few days before submitting tasks, we expect students to regulate their development behavior in accordance with iterative tasks. And this is a question, how to evaluate the valid work. Current systems developed focus on evaluating students' software deliverables, such as homework, quiz, and documents. These systems assume that the audience for the artifact is the teaching staff. Most are evaluated manually, subjectively, and not always correct. Our method is to use an online platform, taking the GitLab platform as an example. Students submit daily or every iteration tasks to GitLab. We can extract the students' learning behavior on the platform. And according to this data, the student's work is quantified and the entropy is calculated to obtain the balance function to judge whether the student's behavior in the development process is standardized. The contribution of our work are automated grading of laboratory environment, collaborative software development process with checkpoints in our teaching platform, and cooperative development contribution model. Traditionally, We can use virtual machine and Docker to check the completion of students' development tasks, or we ask students to develop a project on the cloud platform, and sometimes the teacher will check it out in class. However, these methods are manually. Now, we can let students to upload scripts to online platform. These scripts can reproduce student development behavior, and in this way, our inspection has changed from check experiment to check script. We divided the development process into project start and rapid iterative development, and then set different checkpoints in it. For example, in the project start phase, the software deliverables include prospect and motivation, formation of feature team, user stories, software solution, agile development plan, and food type system. Each deliverables items has a checkpoint. We quantize all checkpoints. Each checkpoint has a weight in terms of importance. As shown in this table, the proportion of checkpoints in project start is 10%, 40%, 20%, 20%, and 10%. Each item of checkpoints is then divided into several sub-items, and some sub-items are evaluated objectively, like auto-check of feature, size sum of user stories, and some are evaluated subjectively, like oral defense and check of documents. And in the iteration phase, different checkpoints are also set, and each checkpoint is set with different weights. And then use a weight to quantify everyone's work. We quantize issue workload WI of issue I as a product of estimate size, time duration, and importance. Workload W is a summation of issue workload. Estimate size of issue I depends on the size of all contributors of this issue. And as the equation 1 shows, WI represents the workload of the ith person in the group, and then we standardize it to get the PI. The entropy HP of normalized workload value P is denoted as the equation 2. Obviously, the larger the entropy is, the more balancing the load is. It is clear that maximum value P, the value of HP is log n if and only if Pi equals 1 over n, which corresponds to the most uniform load distribution. And the balance model is represented by balance function F. As shown in the third equation, balance function is a ratio between the entropy HP and the maximum of entropy log n. So, based on the previous theory, through our experiments, we found that the time that the use of cloud distributing script to check students' work is significantly less than face-to-face checking. The picture on the left is a percentage complete of development job of each project group. We can see that the project completion degree of each group is increasing. Valid time duration of issue is an important factor of workload. And then we analyze weekly time duration of each project group, as shown in the red figure. This is a general upward trend of weekly work order due to online automated grading. Students who get online lower ranking will make more efforts. Time estimate cultivates the habits of finishing work as planned. As the left figure shows the weekly time estimates of weekly workload, it is difficult to keep time estimate habits during the development process. Generally, continuously workload can guarantee the the development efficiency. If the development specifications are met, the team's weekly standard information entropy should be a line close to the level. For example, the purple line in the red figure. Generally speaking, students learn through project-driven and case-driven learning in class, and after class, their work is submitted through the software engineering training platform. In our research, all students experience a team project of software engineering training for 16 credit hours, about 8 weeks. Generally, our automated grading of collaborative software engineering training with cloud distributing scripts worked well. We have got several lessons learned from data statistics and engineering practice. 2 weeks are for project start, 2 weeks are for iteration 1, and 4 weeks are for iteration 2. Finally speaking, our research is to judge the contribution of students based on the tasks submitted to the platform during the development process. That's our research. Thank you for listening.
Okay, thanks for the sharings. Any questions for this paper? Nope. Okay. Thanks all the authors for their inspiring sharings. I think that's all for today, for this sessions. Thank you all to join us today. Okay, everybody can lead these virtual meetings. Thank you guys again for joining us.